So welcome everyone to MTRI's May Sit Back Seminar. So my name is Chad Simmons and I'm an ecologist here at the Mersey-Tobiatic Research Institute. But before we begin tonight, I'd like to acknowledge that MTRI is in and we are meeting from Gespuik, one of the 7 districts of Mi'kma'ki, homeland of the Mi'kmaq people. We acknowledge the treaties of peace and friendship, and we want to thank the Mi'kmaq peoples for their generosity in sharing their homeland with us. So for anyone unaware, MTRI is a research-based nonprofit, and we are settled in Southwest Nova Scotia near Kejimkujik National Park and National Historic Site, and within the Southwest Nova Scotia Biosphere Reserve. Our mission is to promote, conserve, and sustain biodiversity in Gespuik as well as beyond. So tonight, I am very pleased to introduce Thomas Baker, Master of Environmental Studies candidate, at Dalhousie University for our seminar tonight, Where to Conserve Wood Turtles, Developing a Species Distribution Model for Nova Scotia. So next, I'm going to hand the seminar over to Thomas, but I'd like to remind everyone to please keep your mics muted. And if you have any questions during the talk, you can type them into the chat window or save them to the end where you can ask Thomas directly. So that, Thomas, if you'd like to take over.
Awesome, thanks, Chad. As you said, my name is Thomas Baker, and here's my presentation. So see if I have control, there we go. So the first thing, for anyone who is not familiar with wood turtles, this is what one looks like. They're a medium-sized freshwater turtle species that we have here in Nova Scotia, and really throughout a lot of Northeastern North America. So if you see on the right side, we have their range from up here in Nova Scotia, down south along the eastern seaboard, all the way to northern Virginia and West Virginia, and then out to the west through the Great Lakes region, Alberta, Minnesota. They're most notable from their kind of rough shell they have, which actually gives them their species name, Glyptemys insculpta. The insculpta part is that they're kind of sculpted. And then they also have a very vibrant orange coloration on their neck and forelimbs. And this species can be found in habitat that kind of sets them apart from some of our other turtle species here in Nova Scotia. So our other ones we have are common snapping turtles, eastern painted turtles, and blandings turtles. And many of these species you can find in lakes and ponds and rivers and streams and wetlands and many different types of freshwater ecosystems. But wood turtles are a little unique in that they specifically like rivers and streams, specifically meandering ones that generally have moderate flow rates or are slower, lower gradient. And these sort of habitats are important to wood turtles in that they provide deep pools in the bends of the rivers of at least 1 meter in depth, which are good for wood turtles to overwinter in. And then also they provide sand and gravel bars, which the turtles use to nest on. Another thing that separates wood turtles from our other species in the province are that whereas most other species will spend most of the year in and around water bodies, once it starts to get warmer in the summer months, wood turtles are actually moving, as the name suggests, off into the woods, onto land. And during this time, they use a variety of terrestrial habitats, including mixed forests, alder swales, shrublands, meadows, and farmlands. But, here is a wood turtle that I found on one of the surveys we did a couple of years ago, which I wanted to capture in its habitat. It's down there in the bottom right or bottom left. But the problem is, unfortunately, and the reason why I'm doing the work I'm doing is that wood turtles are not doing as well as we'd like them to be doing. Globally, they are considered endangered by the IUCN. And then within Canada and the 2 provinces that I work within, they're considered threatened both federally and provincially. And more specifically, one problem we face in Nova Scotia and New Brunswick, though my talk here today is focused on Nova Scotia, is that we have geographic knowledge gaps concerning where this species is found within the province. And this is really because of historically uneven survey effort, where most effort has been devoted to well-known populations, both in terms of survey effort and directed research studies. And a lot of these surveys that have been gone out to look for wood turtles in Nova Scotia have often either been opportunistic based on local NGOs who are interested in it, or students who have funding and are going to do a project in an area, or they're reactive to development projects. And what this ends up meaning is that many watercourses throughout Nova Scotia have not really been surveyed for wood turtles, or if they've been surveyed, they've only been surveyed a couple times, maybe a long time ago. And this means that our understanding of where they are is lacking. And of course, how can you protect a species if you don't know where it is? Also, the problem of surveying is exacerbated by the fact that wood turtles are difficult to detect. Even when you're going out there intentionally to look for them and find them, they're still hard to find. They're relatively small animals. They don't make any sound. They look, as you saw that sculpted shell, they almost look like rocks often. And often in the summer heat, they're underneath logs or underneath things that are keeping them shaded. So they're very difficult to find. And generally, there's kind of this rule of thumb that was discovered in here in Nova Scotia, that it takes about 7 surveys on a watercourse to really definitively say, if you don't find wood turtles, that they aren't there. And so maybe part of the solution to this, at least from my project perspective, part of the solution is species distribution modeling. And some folks here may be familiar with this term, other folks maybe less so. It's a field that's been becoming more common in conservation work in the last 2 decades or so. And really covers quite a broad suite of different approaches and techniques. But really, I'll just give an overview of kind of the main unifying features between most kinds of modeling. And that is that most models attempt to model a relationship between environmental variables of some sorts. That might be elevation, might be climate variables, forest characteristics, those sort of things. And then model that to the presence, the absence, or the abundance of some sort of species or suite of species. And often the intended output is some sort of prediction, usually in a spatial sense, of current, projected, or the potential distribution of a species or suite of species. So considering that I mentioned that we need data, I'll just run through quickly some of the data that I used for my modeling work with wood turtle. For occurrence data, which are essentially where is the species, or where is it not, depending on what your data is like. I use just the Atlantic Canada Conservation Data Center wood turtle data set for Nova Scotia, which in theory is the most extensive wood turtle data set for Nova Scotia. Unfortunately, though, this data is presence only, meaning that we only have points, locations in Nova Scotia where we know we found wood turtles, but we don't have points called absence points where we have deduced that there aren't wood turtles in the area. And this is important because it affects what kind of modeling you can do. For environmental data, I've collected a suite of stuff, often mostly forestry, topographic, hydrological, or hydrographic data from the open data sources in Nova Scotia, as well as some hydrographic data from the Nature Conservancy of Canada's stream classification layer. And then for my modeling approach, I'm using, or have been using, MaxSense software, and MaxSense stands for maximum entropy. It's well, that's a statistical concept, but the software itself is software that was specifically designed for modeling with presence-only data and creates models that are fairly robust, even when you don't have access to absence data. I also used a process of reverse stepwise elimination, which means that I started with a big suite of environmental variables, all of which I thought may be important to the model. But then I ran a model, and then Maxim will tell you which ones are important and which ones are not important. And I went through, picked the least important, chucked it out, reran the model, one less variable, and kept doing that until I got to a suite of variables that had good model metrics, and then also seemed ecologically relevant. So these are the variables that I started with. I don't need to go through every single one in detail, but you can quickly skim it if you'd like. I have them kind of arbitrarily split up between watercourse variables and landscape variables. And this isn't really a rigorously defined distinction. It's more just a way to show that as I mentioned before, wood turtles, they need particular watercourse characteristics, and that's captured in some of those variables. But then they also use the terrestrial environment quite a lot. So I tried to balance and get a lot of variables that might account for terrestrial habitat as well. And so having done all that, I resulted, after going through all that modeling and picking variables out and throwing them away and kind of shaving it down to what I thought would be the best suite, I ended up with this final model. And so we have an AUC of 0.84, which indicates good predictive power for the model. It's kind of a good score. And then the table I have here is the list of variables in order of importance, from the highest importance to the lowest, that were retained in the model. The highest one being elevation, and then going down through distance to alder stands, distance to estuaries, watercourse density, distance to hardwood stands, standard deviation of elevation, and then also a categorical variable that captures the size of nearest watercourses. The middle column there, permutation importance, is a relative ranking that just kind of speaks to how heavily weighted that variable is in the model. So we go from 50 for elevation, like a very high importance, down to about 2.2 for that lowest variable that I retained. In the relationship, I have a brief description of how, as the variable changes, the score changes for the model, with negative meaning that as the value increases, you have lower scores, and positive being the inverse, and then the size being a categorical one. But I am going to go through some of those top variables and show you some graphs that will illustrate things a little bit nicer. And so on the right, I wanted to provide some sort of visual. Unfortunately, what Maxent does, it produces a grid across the entire study area, so a grid across the entire Nova Scotia, where each cell in the grid has a value, and that value is called a predicted probability of occurrence, or technically a relative predicted probability of occurrence, because it's a relative value from 0 to 1 that indicates some level of how likely we think we might find wood turtles in an area. So if for example, it was 0.7 in a cell, that because it's relative value, it doesn't mean that there's a 70% chance we'll find turtles there, but it means it's higher than a cell that has 0.6 and so forth. And unfortunately, though, because of data sensitivity reasons, I'm not able to show you the actual grid that has the entirety of the province in 250 meter cells. So instead, what I did to have some sort of visual was I averaged those scores within the eco-districts that they fell within, and that's what the map that you see to your right, with the white areas being those eco-districts that had the lower average scores, and then the dark, almost brown or orange color being those more highly ranked eco-districts. But of course, this was less for my own use. I'm not really working at an eco-district level, and more so that I could provide some sort of visualization. And this is just it blown up a bit closer, just so you can take a look. I have the ranges down in the legend, and yeah, so it's highlighting the Annapolis Valley and kind of the lowlands around Truro, the minus basin lowlands as being the highest ones, and then some of those other lowland areas throughout the province, such as the central lowlands along the Northumberland coast. Those sort of areas are also fairly highly ranked. But what I really want to do is show you some of those top variables that were stuck in the model, because it's interesting. The top one for sure was elevation, which came out at kind of the 50% mark of permutation importance, so very heavily weighted in the model. This graph that you see on the left is the kind of response curve that Maxent provides. So the x-axis going along from 0 down at the bottom all the way to about 533 meters above sea level. That's the variable in question. And the y-axis is going from 0 to 1, and that's looking at how the variable affects the score that a cell was given. So here we can see that we have really high, the highest peak is at just above 0, like just not exactly 0 meters, like not exactly at sea level, because there is a little dip, but not too, fairly low elevation, not too high above 0 elevation. And then it quickly tapers down as we increase in elevation throughout the province. I also have a map here just to refresh anyone's knowledge of the elevation of Nova Scotia. But really, I think it's interesting that this variable came in so heavily in the model. And it probably speaks to the fact that we see more of our larger, slower, more windy rivers at lower elevations in the lowlands for multiple reasons. One being that, of course, water goes downhill, so you're gonna have the smaller water courses higher up, and then they're going to accumulate as they go down in elevation. And then also you might have lower elevations because you have softer bedrocks that are more amenable to being worn down and eroded, whereas the higher elevation areas might be harder bedrocks that don't allow for water to cut through them as much, and the water flows faster and more steeply through them. That's possible. That's a possibility. There may also be a little bit of a climatic influence as well, because we see the highest elevation areas are the Cape Breton Highlands, which experience a little more of a boreal climate, which wood turtles might find a little bit too chilly. The next highest variable, which I found was really cool to see it really sticking strongly in the model, was distance to alder at 22.3% of the model. For anyone unaware, alder are a type of, or a genus or family. They're a group of multiple species of tall shrubs that we often find in Nova Scotia. We have a couple species of gray alder, and I'm blanking on my older species right now, but we have a couple species And they often are associated with freshwater, whether it's with rivers, streams, ponds, lakes. Not always, we can find them in other areas, but often they're associated with watercourses. As you can see here in this photo I took on the right, that's actually a photo that I took right next to where we found a wood turtle on one of our surveys. And you can see the alder, which is the shrub on the right side, growing up right next to the river. And obviously you can see this isn't a fast, narrow river. This is a slower, broader river that a wood turtle would find more pleasant. And I think that's probably a part of why this variable is sticking so highly, because we find alder along these watercourses that the wood turtles might like. You're not really going to find alder along a deep, fast-flowing ravine where wood turtles wouldn't be happy. And we can see that in the graph on the left, where we see the highest scores at cells that have a 0 distance to alder, meaning that the cell contains alder, and then quickly dropping off in this kind of stepwise fashion as we move further away from alder stands, really dropping off at 5,000 or 5 kilometers, 5,000 meters. There's also probably, one reason why I found this was kind of fun was because one thing I've heard kind of anecdotally from people who worked with wood turtles in Nova Scotia is that if you find alder while you're doing a survey, it's probably a good sign that you're on the right track. There's a good chance you'll find turtles. And there is also some actual literature from, I don't think, it might be one paper from Nova Scotia or one thesis, but then also some other papers from other parts of the range that have shown that wood turtles will directly select for alder habitat when they're on land versus other adjacent terrestrial habitats. So I think this variable is capturing both a proxy of watercourses, but also maybe some direct habitat selection for alder stands, which is pretty cool. The next variable was also quite surprising to see it come out as being the third most important in the model, and that was distance to estuary. And this was essentially just an identification of estuaries across Nova Scotia, and then moving away from those. Excuse me. And here we see kind of an interesting relationship, some kind of ups and downs, but the general trend is that we peak farther away from estuaries. And this was interesting because I've heard, and the reason why I included something like this was because I've heard from folks who are knowledgeable about wood turtles in Nova Scotia that it's kind of common wisdom that we don't find them in estuaries. We don't find them in the brackish water at the end points of rivers. We're usually finding them, if we're going to find them in a river, we're going to find them upriver in the freshwater. And this appears to reflect that and to reinforce that idea. Though I will say that as this model was built using records of wood turtles found in Nova Scotia, the fact that people have traditionally not thought that wood turtles would be in estuaries suggests that maybe people have thus not surveyed in estuaries, which would lead to less occurrence points in estuaries, which would then lead to a lower score in this model. So there may be some sampling bias at play, which just really further lends support to the idea that we need to do more research into, are wood turtles using estuaries? Are they okay with brackish water? Are they in these areas? Because currently the model is saying maybe not, but I think more research is warranted. And then finally, the last variable I want to show, the fourth highest variable in the model, was watercourse density. This is also an interesting one because originally in my earlier modeling, I had used just a basic distance to watercourse variable, which had been retained. But then when I incorporated watercourse density in a later round of modeling, it bumped out distance to watercourse as like the kind of direct watercourse variable. And I think that's potentially for a couple of reasons. One, obviously, if you have watercourse density, that in an area, that means you have watercourses, it means there's watercourse habitat. But I think also, because as we see on the graph here, we see a very simple increase in, as watercourse density goes up, we have higher scores. And I think part of it, and the reason why I have this kind of crude little figure on the right, is that if we look at these three rivers, we have a straight river, a sinuous river, and a meandering river. Wood turtles are going to generally prefer the sinuous and meandering rivers over the straight ones. And I would say that if we put a square around these three rivers and then calculated how much kind of river was in that square to calculate a watercourse density, we'd get higher densities as we went down that list from straight to sinuous to meandering. Because if you look at the meandering especially, we're getting that bending back and filling up more of that area. So potentially, I think this variable is important because it not only says watercourses are an area, but also speaks a little bit to maybe some more bending, more meandering. more braiding potentially, which wood turtles would, in theory, prefer in an area. So those are the top 4 variables. I also have graphs for the other 3, but I can look at those if people have questions later on, but I'm going to pop over from there. Because obviously we want to make these models for a reason. We want them to be useful. A model just for a model is not good enough. So the first most direct reason we made these models was to prioritize field surveys. And we've done that both last year and this year. I shared my model results with the provincial departments in Nova Scotia and New Brunswick, the Nova Scotia Department of Natural Resources and Renewables, and the New Brunswick Department of Natural Resources and Energy Development. And we intentionally prioritized sending staff out to areas that were highly predicted in the model, but that didn't currently have wood turtle occurrences in a certain area. For Nova Scotia, we used a radius of 2 kilometers. So if we didn't go to places that were within 2 kilometers of a previously known occurrence, because we wanted to capture those areas, those gaps. And in 2021, based on my earlier model I'd made, we found new wood turtle occurrences in 2 Nova Scotia watercourses. And this talk is about Nova Scotia mainly, but I don't want to not mention the 5 that were found in New Brunswick watercourses, which is also exciting. And then as we're speaking right now, well, I guess not currently at 7 o'clock at night, but this time of year, we also have staff once again out looking for turtles with the newer model. And we have, as of now, as of whatever date it is, May 26th, we found new wood turtle occurrences from 2 more Nova Scotia watercourses, which is very exciting. I wish I could tell you where they are, but for data sensitivity purposes, it's all secret information. But it's very exciting to be finding wood turtles in places we've never found them before, or at least people might have found them there, but where we've never recorded them as being, because it helps to expand that knowledge. And then also, there's this greater piece from the field surveys and from the modeling, we want to be identifying habitat. And there is obviously a communicated need to identify the current distribution of wood turtles, both from government and from academics and NGOs. People are interested in finding where they are. This is for both designating and refining our core habitat designations, or refining our core habitat designations in Nova Scotia, and then also maybe, if we can, prioritizing areas for land protection. So one thing I did to kind of explore what the current situation was like, at least based on my model, and I included this figure on the right to kind of help explain what I'm talking about, because if we look at the leftmost box, that's what my model kind of looks like. Obviously, my model is not in South America, but it's a model where the entire study area, or in this case, looks like Central America, the Caribbean, and kind of most of Northern South America, is covered by cells. And each cell, or each grid cell, contains some sort of value from 0 to 1. But a common thing you do when you're doing modeling like this is you find a threshold, and usually Maxent provides a couple thresholds that it builds using its own statistics. And you use these thresholds to kind of cut off that continuous distribution and turn it into everything above the threshold gets a 1 and everything below the threshold gets a 0. 1 being presence or potential range or predicted suitable habitat, and a 0 being the absence of any of those things. So I used a threshold that Maxent provides and did that, and created a map of kind of the potential range of wood turtles in Nova Scotia as the model predicts them. Unfortunately, once again, I cannot show you that for data sensitivity reasons. But then I took that and I overlaid it with our current protected areas system, and also with the current Nova Scotia core habitat layer for wood turtles, and found that 2.26% of the predicted range that my model predicted currently overlaps with the current designated core habitat. And then also only 4.59% of it overlaps with the current protected areas system, which are obviously fairly low numbers. I think they speak to, and then together, when you combine those two layers, they cover 6.81%. And that's not an exact addition, because there's some overlap between the protected areas system and the core habitat layer. So obviously those are not super high numbers, which does definitely suggest that we have more work to do. But I also wouldn't get too worried about not having really high numbers, because also the model is definitely predicting areas that probably don't have wood turtles, because it's casting out quite a broad net. But I would say overall that these numbers do suggest we have some work to do with identifying habitat and increasing our protections for wood turtles. One thing I also noticed was, and I can only speak in generalities because I can't show you the map itself, but I noticed a lot of the suitable habitat or the potential range that was identified was in the agricultural parts of the province, was in the low-lying kind of river valleys of the province, where there is a lot of farmland, there's B, a lot of privately held land, not a lot of crown land is held in these areas, and C, as a result of, I think, both of those things, there's not a lot of protected areas. I think for a couple different reasons. One, I would say because these lands are being used actively for agriculture, so there's kind of an economic point of we don't want to turn that into protected areas. And then B, a lot of it's private land, so it's expensive for government to acquire it. But I also think the main reason might be C, that when we go out as a society and we say we're going to protect some land, we often look at the places far away from lots of humans and say let's protect that, and we don't often look at the denser agricultural areas where some species actually may need those areas, and they'd be great places for protection and restoration, but they're not seen as maybe as pristine or as special as the kind of forests and hills and coastlines that are farther away from human settlements. So maybe this is also a pitch for, let's maybe, if where we can, conserve some of those areas that we don't normally think of, because it seems like those sort of areas are the ones wood turtles like, and maybe with a lot of the human settlement and development over the last couple hundred years, we've crowded out wood turtles in a lot of those good areas. So yeah, in conclusion, my model predicts high probability of wood turtle occurrence at low elevations within Nova Scotia, close to alder stands generally, far from estuaries, or at least upriver from estuaries, and then also in areas that have higher watercourse densities. It has been awesome, it's been awesome. It's been used successfully to find new wood turtle occurrences, but obviously further work remains for further surveying, habitat identification, and protection of these awesome little creatures. Yeah, I hope that all made sense. These are my acknowledgements. There are lots of great people and great organizations who have helped me in different ways, whether it's providing data, expertise, lots of wonderful people. These are my references, and then I'd be happy to answer any questions. Thank you for listening.
Great, thank you, Thomas. Does anyone have any questions? I have a few questions. So I'm just kind of curious if I can dig into the statistics a little bit. What was your sample size like, Thomas?
For sure. Do you mean like the number of points I used?
Yeah, I'm just kind of curious, like how many wood turtle sightings has there been? Like dozens or hundreds or thousands in Nova Scotia to build your model?
Yeah, so the data set includes, I don't have the number of how much the full data set was, but it was in the tens of thousands. But then because of that sampling bias, that survey bias that's happened, a lot of them were clustered in certain parts of the province and certain water courses. So I didn't use all the data as I got it. I did do a process of thinning it, and I chose a thinning parameter of about 500 meters. So for every 500 meters, I only retained one point, and that ended up with 607 points that I used for the modeling.
Would you say that's like ideal? Obviously, you'd want more, but do you think that's like a fair middle ground?
I think that's a good amount, because you don't, if more means that you're just doubling up in the same area and you're kind of double sampling an area, then more isn't necessarily better. And really, if you look at some of the species distribution modeling literature, some people have done modeling where they've had like 30 points over a much larger geographic area. So I would say 607 feels comfortable to me for the modeling purposes. And also, I would say also MaxScent has been one of the, besides being good at using presence-only data, another benefit of MaxScent is that it does seem to hold up pretty well even with small data sets. And I don't think mine would be considered a small data set, but it does well with them.
We have a question from Cindy Stacer. She asks,
Hi, Cindy.
she was wondering if the association with agricultural areas might mean that the turtles like richer habitat, so higher in nutrients.
Hmm. That's a really, really good question. I don't know if I've read anything that's directly talked about kind of nutrients in the soil and wood turtles. I could see it being a fact. I mean, they eat a lot of things. They kind of eat anything that's energy dense enough that fits in their mouth. So berries, flowers, mushrooms, slugs, earthworms. And I guess you could theoretically, maybe there'd be more, well, I don't know, there's lots of berries in low nutrient areas. One thing I would say is I did have the distance to hardwood stand in as a variable, and that stuck. And generally we think of our hardwood forests generally in Nova Scotia as being more nutrient rich areas versus mixed forests or softwood forests. So I don't know if it would be a direct nutrient relationship. At least for me, the hardwood stand as being an important habitat feature is more some of the thermodynamics of wood turtles, because they are an ectothermic species. They need to warm themselves up, but then also they need to stop themselves from heating up too much. And hardwood forests, or at least broadleaf trees, are really great for that, because early in the spring or in the springtime, when turtles are first coming up on land and it's still a little cold, there's no leaves on the trees. The sun can penetrate the canopy really easily. They can get a lot of that energy that they need to be active. But then once it's summer, once it's really July and August, and it's getting really hot, and it's actually too hot for these turtles to be out in the sun directly, all these trees have leafed out and suddenly there's tons of shade. So for those sort of reasons, for like thermodynamic reasons, I'd say more broadleaf dominated forests would be preferential to more coniferous forests, and that could be tied to nutrients in the tree compositions.
Sherry asks, what is the current estimate for wood turtles in Nova Scotia?
Yeah, I think Chad, you put it in the script. I think one of the descriptions you had like 2,500. It's pretty variable. I'd have to double check the COSERIC report, but it's, if I remember correctly, it's like anywhere from like 2,500 to 7,000 or something. It's a very broad range. Suffice to say, I think it's more important to just say we don't really know. We don't, because we first don't really know where all the populations are, and then even of the populations we know of, we don't necessarily really have strong population estimates for them. So some amount of thousands of turtles, but it's pretty unclear. I'd have to double check what exactly people are saying, but that's the case.
Cindy's also asked, what about water pH?
Yeah, I haven't seen anything in the literature that strongly leans one way or the other about them needing a certain pH. I did have I believe I had, maybe I didn't, just pop back. It didn't end up sticking in the model, so I can't remember. Yeah, I did have an alkalinity of nearest watercourse variable, which was a categorical one. So it wasn't very involved. It wasn't like a continuous measurement anyway. It was just kind of like low alkalinity, kind of a medium and then a higher one. But that never really stuck. It was never pulled out as being important. So I haven't seen in the literature, it didn't really hold up in the modeling, but I would say I didn't have a very rigorous, wasn't a super rigorous variable for it, mostly because stuff like that's difficult to actually get on a scale that covers an entire area. Because when you're doing this sort of modeling, you need your environmental variables to cover your entire study area. You can't have, oh, we have information for this river, but not the next one over. We need it for everywhere, which does limit some of the variables you can include.
Holly asks, do you include iNaturalist or Turtle Patrol sightings in your work?
I did not in this case, but it's not because I'm necessarily opposed to it. I guess for this case, I just used the data set. The only thing with the iNaturalist ones, I know that they're often, I believe they need to be, their locational data is obscured in iNaturalist because it is a data sensitive species. And I'm not sure exactly what the kind of licensing looks like for that, because I have downloaded iNaturalist data for other applications of other species, but I've never done it for wood turtle itself. And I'd be curious, I don't know if the person asking the question knows, but I don't know if I could get the actual exact location from my naturalist, which I would need. You need pretty good accuracy for this sort of thing.
I have heard that for researchers, iNaturalist does share that sensitive data. So that might be something to look into, Thomas. Just
Yeah,
speaking about Turtle Patrol, the organizers of that Facebook group have been a little bit hesitant to share that data with researchers and the government departments. So, to my knowledge, and I could be wrong, that information really doesn't go anywhere, unfortunately.
yeah, I'm not sure. I pretty much just worked with what the government data sets had for this project, which it still seemed they're still fairly extensive, and I think a pretty, for what we have, fairly representative. But there more data is always better for things like this.
So Tim asks, I noticed your model doesn't show the St. Mary's River as being likely habitat, but we know that that area is of potential interest.
Yes, so that's mostly probably, as I said, this isn't really a true visualization of the model. It's averaged up to eco district. So I wouldn't, the fact that St. Mary's isn't highlighted here is not indicative of the actual model. It's just because the St. Mary's area is divided between two eco districts, I believe. It's like this one. I don't know. Can you see my mouse when I'm?
Yeah, we can.
Yeah. So this is one eco district, and then there's a eco district here, which both kind of make up the St. Mary's River area. And I think just the size of them and the fact that much of those eco districts is high elevation means that when I visualize it in this way, you lose the actual river itself and the lower elevation areas around it. So without saying, I mean, I can't say too much, but the actual model has a better look for the St. Mary's River than this visualization does. It's probably as much as I can say. But this is just because I guess I didn't really explain, but for anyone who is unfamiliar with wood turtles in Nova Scotia and wood turtle work, I threw around the term data sensitivity a lot. And that's because wood turtles are a species that has been, I'm not sure if there's ever been instances in Nova Scotia, but has been in other parts of its range in the States poached for the pet trade. And not just like small time little things, like actually quite organized crime where people go out, they collect turtles and they sell them on the market. So as that is a threat to, and a very strong threat to wood turtle populations, because with turtles like this, even a single loss of an adult from a population in a year is quite disastrous because they're so slow growing. It takes so long to reach maturity. So because of that fear of data like this being used by poachers to go out and target turtles, that's why I often can't show more fine, coarse models or maps.
Yeah, and it's that exact reason why MTRI always cautions people, and we really encourage you not to share location data for species at risk. It can cause a lot of harm.
Yeah. If you do find a wood turtle, I definitely recommend contacting someone, whether at Natural Resources or at MTRI. I know Jeffy at MTRI is very in tune and in touch with the whole wood turtle situation in Nova Scotia. So definitely contact someone in the know and someone who's kind of hooked up, but don't post your thing on Facebook or Instagram or something like that and say where you found it for those reasons.
The Clean Annapolis River Project is also a great organization to contact.
Yeah, they're also great, especially if you're in that area. Katie is also does some great work there.
So someone asks, oh, this is Tim again. I believe SMRA, the St.
Mary's River Association?
Mary's River, that's it, association, is working on getting a wood turtle monitoring program started in the river. And he wonders, is it possible to get some level of access to your model so that they know where, or like they can potentially prioritize areas?
For sure. We'd have to, everything needs to be kind of parsed through government because I'm working with them and through the Natural Resources Department. Everything has to be okayed, but maybe, is there a way I can share my email and we can get in touch? I don't know, I didn't think I included it on a slide.
No, but you put it in the chat.
Oh, perfect. Yeah, I'll do that. You can definitely get in contact. I can't promise anything for sure, but I'd love to Let's see what we can do. Because what is a model if it's not useful? There you go.
So Malcolm asks, for the areas where wood turtle surveys are being conducted based on your model, are the surveys looking for the presence of the turtle or looking for populations through mark recapture, or both?
Just simple presence. They're very, the idea for these surveys was very much just cast a net to as many places as we can get to, try to cover as many places that haven't been touched before, more so than more intensive population estimates. In theory, those projects like that are what we need to do after we have a better idea of where they all are, or concurrently, but we first need to know where they are.
So some people are asking through Facebook, how do you identify a wood turtle?
It's a good question. Thankfully, we don't have a lot of turtles, or not thankfully. I was actually just down in New York recently and at a conference, and I was astounded by how many turtles there are in the Eastern United States, which is cool. But in Nova Scotia, we only have the 4, unless you also count red-eared sliders, but they're not supposed to be here. And generally, I wish I had an image or something, but you have the 4. So Eastern painted turtles are kind of your basic pond turtle. Maybe I'll go back up to my photo of a wood turtle. I think I've lost, there we go. So an Eastern painted turtle has a smooth shell and looks very much like a generic pond turtle, and it has kind of flecks of color on its head and arms, but not like a consistent color. And then snapping turtles, which you're probably familiar with, are the big, nasty looking ones. So kind of difficult to confuse with this very cute little turtle here. And then Blandings turtles are similar to painted turtles in that they have like a smooth shell, more domed than this one. And they do have a consistent color on the front, but it's bright yellow. So really, like I was saying earlier, the big features to look for wood turtles are this really rough shell, really rough and as the name would suggest, sculpted. And then the really bright, vibrant orange color that you can see. I think you can see it better on my questions slide. You can kind of see it. You can kind of see a little bit of orange on the front of the limbs here. This is not as vibrant, but here you can get a little bit of the orange. So that orange color, an orange versus a yellow, really, I think would be the best way to, and that shell texture.
Great. Do you have some tips that people can take to, if they encounter a turtle, like what, or better question is, what can people do to help protect wood turtles?
For sure.
Especially if they own land in areas that potentially could have them.
Definitely, if you own land, if you own any sort of stream front or river front, the most important thing you can do is to maintain as much of that riparian area as possible, as natural. So the worst thing you could do, the absolute worst thing you could do is to, you've probably seen this in some rivers where you pile a bunch of rocks into the shoreline of the river, like I don't know, it's called a riffraff or something, like massive boulders and stuff. Because once you do that, that whole riverside is totally useless to a wood turtle. They can't get over that. So if you are concerned about erosion of your land along a river, instead of using that hard kind of guarding material like rocks, I would suggest more promoting the natural growth of riparian vegetation, whether it's like alders or other plants that might keep the bank a little more solid, but keep it more accessible to wood turtles. So yeah, riparian buffers or riparian habitat is very important. The other thing is, if you're a landowner, if you do any sort of haying or mowing, that's a time when wood turtles are very at risk, because they like to come up into meadows and fields to look for earthworms and flowers and other little things. And a lot of them often get killed by usually more industrial kind of scale like hay mowers. But if any folks here do that sort of work, there are some different tips and tricks you can do to reduce the likelihood of hurting wood turtles. Some of them involve not haying during the peak times that wood turtles will be out in the fields. Some of them also involve raising mower blades so that they're less likely to hit a turtle. Or if you're really dedicated, as many people here might be, you might even, if you're going to do that, you might want to go out into your field and do a walkthrough first and see if there's any turtles in the grass. That would really limit the possibility of running them over. The other thing too, another thing that is dangerous to them is our cars on roads, places. Really, the big things for wood turtles are being run over. Being run over is the worst thing that can happen to a wood turtle. So if you do see a wood turtle crossing a road, generally I would say if you see a wood turtle anywhere, don't interact with it. Give it its space. Don't go and pick it up. Let it have its nice little day. But if you do see a wood turtle crossing a road, it wouldn't hurt to gently pick it up and then try to keep it as low to the ground as possible so you don't accidentally drop it, and gently bring it to the side of the road that it's trying to get to. Whatever you do, don't pick up the wood turtle and bring it to the side it's leaving from, because it'll probably just try to cross the road once again. Turtles are very stubborn animals that they know what they want to do. They know where they're going. They usually have lived in an area for a long time. They have a mental map of where they're going. So if you see one, bring it to the side it wants to go. And then, I'm not sure, I'm thinking of other things that would be good. Yeah, that's a little snapshot of things.
And if anyone else is interested in learning more, I know the Clean Annapolis River Project does have a lot of material, and you can call them up. They would be very willing to talk to you, especially if you do own a farm, because they have a whole program dedicated to that and protecting wood turtles. So I really recommend anyone to reach out there if you have questions. And just on the topic of moving turtles on the road, please only do so if it's absolutely safe for you to do so, and if the turtle is in immediate danger. If it's an old dirt road that's not traveled, it's not necessary to move the turtle.
Yeah,
that's just covering our bases.
Yeah, don't get yourself killed trying to save a turtle, or get someone else. Don't cause an accident. Turtles are important, but people are important too.
So I had one more question about your model predicted areas. Didn't really overlap much with the core habitat that the province has established. Can you tell us more about how that core habitat is decided?
Yeah, so the core habitat is very strictly generally defined, and I always, if I'm wrong, maybe Lisa's in the chat, or in the call, she can correct me. But it's defined as, so the province or the country, sometimes I can't remember, federal or provincial, but generally the province finds that wood turtles, we have a wood turtle point here, and then the wood turtle point is associated with the watercourse, and then you identify core habitat 2 kilometers in either direction from that point, and then this is where I'm terrible with numbers. Numbers always slip my mind, but oh, is that Lisa?
Yeah, Thomas, I'll interrupt you because what you're talking about is how we identify significant habitat. But for core habitat, which is actually a legislative term under the Nova Scotia Endangered Species Act, and in Nova Scotia at this stage, what we have done is adopted the federal recovery plan for wood turtles under SARA, and they've identified critical habitat, which is basically the same thing, only critical habitat is a federal term and core habitat is the provincial term under our legislation. And at this time, we've adopted what Environment and Climate Change Canada has designated as critical habitat under the federal legislation. So we've adopted that for Nova Scotia at this time. We haven't developed a separate analysis for core habitat as of yet.
Thanks, Lisa.
So that was probably really confusing for everyone.
Well, I find like significant, critical, core, all these terms just blend together in my head, and it's hard to keep all of them separate.
It is, but yeah, at this point, it's largely defined as those major watercourses that have well-established turtle populations in Nova Scotia that most people involved in wood turtles would already know about. Those have been designated as the critical and core habitat.
Thanks, Lisa.
Yeah, thank you. And just, I guess, one last question from our Facebook stream. What are some natural predators for wood turtles?
Yeah, so it's really many of what you call like mesopredators. So coyotes, otters, even raccoons, a lot of these species can predate on wood turtles. They don't often do, but they can, especially, well, babies. Babies get eaten all the time. Tons of babies get eaten. But for adult turtles, some of these mesopredators will eat them occasionally. Oftentimes you'll find turtles that have lost a leg, or they'll have their tail bitten off. So it seems like oftentimes a predator like this, like a raccoon or a fox or something, will come along and grab a little bit of a turtle and then take that. But it is a concern when we think of subsidized predation, and we think of human development, whether it's agricultural or urban, because often in these areas you have elevated or artificially elevated populations of things like raccoons, foxes, coyotes. A lot of these mesopredators really benefit. Well, not all of them, like otters don't really benefit, but like raccoons, foxes, coyotes, they benefit from human infrastructure, whether it's farms or trash or things like that, which can often lead to a detriment to the turtles themselves, because the more of those animals that are in an area, the more likely we have these little incidents where they get maimed or killed by them. But generally, as a species, as turtles, they don't face a lot of adult mortality. And that's one of the reasons why turtles as a whole group are so heavily threatened by human activity, because even a tiny uptick in the amount of adults that die a year is disastrous for turtles, because they're so adapted to essentially being little tanks once they're an adult. And their whole life history is built around that.
Lisa asks, what about nest protection?
As a strategy for helping them?
No, sorry, that was nest predation. I was just wondering about.
Sorry.
Yeah, so eggs and baby turtles get predated by multiple species such as raccoons, and I would assume coyotes and foxes as well, but raccoon seems to be the one I often hear about, digging up the nests, eating the eggs. And maybe generally in a more kind of natural pre-human development situation, that would have been normal. The amount of predators digging up nests would have been okay, and turtles were adapted to that. But between the increases in adult mortality because of being run over and the increases in predators that would feed on nests, it probably does have a larger impact than it used to have.
Great. Okay. So with that, thank you again, Thomas, and thank you everyone for joining us tonight. You can catch MTRI Sit Back Seminar Series again next month on June 30th for our next talk, where we will be joined by Dr. Christopher Edge from the Canadian Forest Service for his presentation on if there is a risk of using, and I'm going to pronounce this wrong, imidacloprid to control hemlock woolly adelgid, an invasive species that's substantially decimating our native hemlock.
That would be cool.
That would be really interesting. So with that, I'd like to thank the Region of Queens for supporting us in our seminar series. And as always, if you want to stay up to date with our seminars, you can follow us on Facebook. And if you'd like to watch tonight's talk again, you can check out our Facebook page or our YouTube channel where they'll be posted. And with that, we hope everyone stays well and we get to see you all again very soon. Thank you, everyone.
Thanks, everyone.
Thank you, Thomas.